Hi, welcome to another episode of Out of the Blue. I'm Blue. Today we're going to be talking about something that's kind of important but maybe underestimated by a lot of people, and that is zeros and infinities. I know you're probably familiar with these ideas, but maybe we need to get the concepts a little further down so that we can really understand limits and stuff like that. So let's get started. We're going to start with the concept that you're probably more familiar with, and that is zero, the big goose egg, nada, nothing, zip. Well, you're probably familiar with that because you can imagine having nothing. I have $0 in my hands right now. If I tried to distribute that amongst all of my friends would get $0 because I have nothing to give. That kind of makes sense just on a logical level. Well, infinity is kind of harder to grasp because infinity is limitless. There's no way for me to have infinite dollars. I wish, but there's just not, because no matter how many dollars I have, if I had another dollar, it would be more than that. And that's kind of the definition of infinity, is that you can't have any more than infinity. It's limitless, it's huge, and that's what we're talking about next. A lot of people and math teachers alike like to tell you that infinity is just sort of like a really big number. And when you're working with it, that might make sense and it might be really useful to think of it that way. But infinity itself isn't a number at all. It's just a concept meant to represent an infinite number. I know I used the word in the definition and that's not cool, but really that's just how to explain it. Infinity is a number without limits. It goes on forever, and there is nothing bigger than infinity except another infinity. That's another thing. Infinities can all be different sizes. So if you have infinity divided by infinity, that doesn't equal 0, because you could have, infinity on the top being the amount of numbers between 0 and 2, and infinity on the bottom being the amount of numbers between 0 and 1. Well, even though they're both infinite, the infinity on the top is bigger than the infinity on the bottom. Neither can be really conceptualized, but once you work out the equations, you solve the quadratic, stuff like that, you can figure out which infinity is bigger based on coefficients and stuff. And that's kind of really difficult to think about. I know it's a kind of cliche, and Fault in Our Stars is like, there are bigger infinities than others, but that's really true in math. So you can't just settle for an answer of infinity because it's super big. If you need to figure out a ratio of infinities or ratios with zeros and infinities, figure them out because they're very important. Real topic for today is limits. Limits as you approach 0 and limits as you approach infinity. In order to understand limits, we need to understand zeros and infinities. So let's say you're taking the limit of an equation as it approaches 1. Well, you're kind of going up to 1 and really getting close to it, but not quite touching 1. How close are you getting to it? Well, that's approaching 0. You're so close that there is no number that you can imagine that is closer to 1 than the limit as you approach 1. But you're not quite there, because if you were quite there, the equation might not exist, there might be an asymptote, there are things there that maybe are preventing you from actually getting to 1, and that's where limits come in handy. Limits at infinity are especially important because let's say you have an equation and you want to figure out what it does at the very end of the graph, which is infinity. This is called end behavior. If the graph kind of goes to a single number, you want to figure that out. If it goes forever and it keeps going up and up and up, then you want to know that it goes to infinity. So what you do is you find a limit at infinity, which means you are going as far as you can out and figuring out what the graph does there. You don't do this by plugging in really big numbers, because whatever huge number you can think of, you could just multiply it by 2, and that would be an even bigger number. That's kind of the thing about numbers, is they're never ending. So you have to figure it out by plugging in infinities and stuff. And that's kind of complicated. I'm only talking about the conceptual stuff today. So you just use a limit as you approach infinity to get super far and figure out what a graph or an equation or a summation thing does. This is going to be really useful next week when I talk to you guys about the number e, which I can't do a hand symbol for. But e is really cool because it involves a series and the limit of the series as it approaches infinity. Limits as you're approaching 0 come in handy when you're in a situation like the one I said before, like when you're getting super close to 1, but you can't quite touch 1. What you're doing there is the space between the line you're drawing and 1 is the limit as n approaches 0. So your space is getting infinitely small, which means it's approaching 0. Because 0 is kind of an infinity that way, and that it's infinitely small. So everything's connected, everything is the same, it's all in harmony, and math is great. That's about it for now. I just want you to kind of think about infinity and 0, because I think they're really kind of fun to think about, just playing around with the ideas in your head. And it'll be really helpful. Like I said, next week we're going to be talking about E, which is my favorite real number. Pi is a close second, but E is really cool and it comes in handy for a lot of stuff. So tune in next week, and thank you for watching.